A very good afternoon, everyone. So, in this case, in this chapter, first of all, we are going to study the input source current waveform. How the input source current will vary, what will be its nature. So, and that too, the input current waveform of a three-phase full bridge rectifier will be discussed. So, till the last lecture I had discussed that in which order the switches will be fired. So I will be continuing from that part, and only from that part we will be very easily able to deduce the input current. So please have a look at this. How we will deduce the input source current nature. Look at this. So T1, T3, T5, T4, T6 and T2. Now the firing order is, the conduction order is 5 6 6 1 1 2 2 3, okay, 2 3 3 4 4 5, again 5 6. Clear? So the conduction will be something like this. 5 6 will conduct. When 5 6 will conduct, then the output will be, have a look at this, 5 gets connected to the C part, and 6, where's the 6? 6 is this part. This gets connected to B part. So the output voltage will be VBC. I think we are quite clear. The output is going to be V, not BC. It's going to be VCB. Okay. After that, coming back to 6 1. When 6 1 will get fired, then again you can look at one. This is connected to A. Okay, and this is connected to 5 6 and 6 1 6 1 6. That's B. So we are going to get the output voltage VAB. After that, 5 6 6 1 and 1 2. Have a look at this. 1 is connected to A. Have a look at this. The connection is made to source A. And 2. Have a look at this. 2 here. If 2 is fired, then 2, the wire gets connected to the load current, and 2 gets connected across C. Clear? So the voltage variation now becomes quite clear. First of all, VCB will conduct. After that, VAB will conduct. Then we will get VAC. Then again VBC, VBA and VCA, and so on. This was the order of voltage, because the understanding of the order of voltage is very important. If we are not able to understand in which order the voltage is coming out, then we won't be able to understand the source current waveform. Yes, because source current waveform is very, very important. It will, because after that we have to do converter analysis. So we would be able to do converter analysis only when we will understand the source current. So once again, now coming back to the conduction. Okay, one more thing, very, very important thing that I want to shed light is that in this part, the part which I am discussing, because I had already shown you that 5 6 will conduct, it is not mentioned clearly that at which value of alpha the conduction is going on, because alpha has to be decided. If alpha is known, then only you can trigger a thyristor. But if alpha is not known, then you cannot trigger a thyristor. So in this case, have a look at this waveform. Have a look at this. Okay. At alpha equals to 30 degree. Yes. At theta equals to 30 degree. Why? Because the line voltage will be, in case of a balanced system, the line voltage will be leading the phase voltage by 30 degree. Right? Because we all know, have a look at this, if this is your phase voltage, this is going to be line voltage 30 degree, and okay, so it is leading by 30 degree. Okay, so we can easily understand that this waveform will be leading. If this is the phase voltage, then obviously this will be leading by 30 degree. It means leading means omega t plus t. Yes, omega t plus 30. So omega t equals to minus 30 it becomes, so it will be shifted towards this direction, towards the left direction. I think I am quite clear. Okay, leading waveform. So this CV part will go like this. Okay, shifted a bit by 30 degrees. Now that shift is assumed to be the zero origin in our case. Okay, so now the waveform analysis becomes quite easy, very easy. Yes. Okay, so if alpha equals to 0, then we can say that okay, this part is, this is alpha equals to 0. Okay, and this waveform will be at 30 degree. Okay, are you getting it what I'm telling you? Yes. Okay, so something like this. I think it is clear now. This part is quite clear. Until it is not fired, then VCB will be occurring across as the output voltage. Now this is for alpha equals to 0. Now if we want displacement in alpha, for example, have a look at this. If alpha is 60 degree, then obviously from this part, okay, from this part it will be displaced to 60. Okay, so obviously this will be 90 degree peak. Are you getting it? Because it was 30, so it is going to be 90 degree peak. That's why I have shown you the peak voltages directly. For alpha equals to 90, the conduction will begin from theta equals to, no, for alpha equals to 60, the conduction will begin from theta equals to 90 degree. Clear? I think very, very important. This part is very, very important. So if this is clear, I will come to the value of alpha equals to 90. But if you look at the source current, then source current will be for different phases. For example, phase A, phase B, phase C. And we can very easily draw those parts. It's very easy to draw. We just need to look at the different values. For example, this is VAB, VAC. Here A is at the top. It means when VAB is the voltage, then T1 and 5, 6, 6, 1. Okay, 6 is in the bottom, so 1 is conducting. So A is connected, and after that we are getting the voltage as VAC, AC. Okay, no, VAB, VAC, correct. So for AC case, I can directly say that T2 is conducting. So when A is conducting, then the current will be flowing something like this, in this direction. Okay, from the source. Okay, from the source to the load, then it will either enter T2 or it will enter T6, and it will go back to the phase. I think it is quite clear. Clear? I think it is very much clear. Now, if we are getting a voltage VCA, then obviously the switch in the upper leg of C, this thing will conduct, and A part is 4. So like this. Okay, this C, okay, C, A, it will go, and it from T4 it will enter the source. Are you getting it? The current will move through T4 and then it will enter our source. So it becomes very easy and simple to understand that the source current will reverse its polarity. Once it was positive, now it will become negative. Okay, we can very well understand, and thus the waveform of source current will be obtained. So this is very important, because if we are able to understand these things, then we can easily plot the graph. Similarly, we can obtain the graph of IP also, that I will discuss in the next class. Thank you.